Hello everyone, my name is Xin Chen from the National Tsinghua University in Taiwan. It's my great pleasure to introduce our research on predicting and suppressing the non-stationary pathological oscillation we observe in Parkinsonian rays. And we do our experiments by an adaptive wireless neuromodulator. So in our experiments, we use 6-OHDA to lesion the dopaminergic neurons in the nigrostriatal pathway. And we can see that after the 6-OHDA lesion for 3 weeks, in many brain regions related to the Parkinson disease, we have the pathological beta oscillation growing. And this pathological beta oscillation can be suppressed by applying different stimulation to the subthalamic nucleus. And in addition to the pathological beta oscillation, we found that there is another pathological signature called high voltage spindles. If we look at the time frequency plot corresponding to the high voltage spindles, we can see that it has a very different time frequency features compared to the beta band oscillation. So we are curious about the biological question. Is the high voltage spindle actually the pathological signature for early stage Parkinson disease? The device we use is the New Life, which is based on the biochip developed by my lab that includes neural recording, neural stimulation, and optogenetic drivers for LEDs. So with this chip in the headstage, the animals is able to move freely during our electrophysiological experiments. In addition, the controller here is able to control more than 4 rats simultaneously to facilitate big data collection and the behavior study. And most important of all, the system is designed to implement a different type of algorithm to detect pathological signatures for neural disorders automatically. Once the pathological signature is detected, the system is able to trigger stimulation precisely at the precise timing to suppress the pathological activity in the brain. So the algorithm we implement is called the adaptive autoregressive modeling, and the model is actually trained by the Kalman-filter during the recording. So we can see that with online learning, the autoregressive model is able to predict the local field potential faithfully during the recording, such that we are able to detect all the high voltage spindles in the recording with a mean precision up to 94%, and the latency is always less than 100 milliseconds. So I'm going to show you a video demonstrating that the new life system is able to detect the high voltage spindle in real time. Whenever the amber light here should light up, it indicates the detection of the onset of high voltage spindles. So here is the video, and we can pay our attention to the amber light here. Whenever there is amber light, we can observe the high voltage spindles on our right hand side on the screen. So the next question is, whenever we detect a high voltage spindle, how long should we apply the stimulation? The table here shows that the mean duration for high voltage spindle is around 3.6 seconds, but we actually choose to apply stimulation for only 0.2, 0.5, or only 1 seconds. And interestingly, we found that at 0.2 seconds of stimulation is already sufficient to suppress the high voltage spindle from a mean duration of 4.0 seconds to only 0.47 seconds. So The results here demonstrate that closed-loop precise stimulation actually helps to reduce the stimulation dosage significantly, and it can suppress the hybrid spindle with high efficacy. Thanks very much for your attention. If you have any more questions, you could email me for more discussion. Thanks again.